Hello and welcome back, guys. This video is going to be on binary trees and how to represent them in JavaScript. In that sense, this is going to be like a prequel to the binary tree visualizer library video, using which you can easily visualize binary trees in JavaScript. So if you haven't watched that, you can head over there after this and visualize your binary trees. So first of all, this question will definitely come up, and that is, should you learn binary trees in JavaScript? And to that, my answer is, of course you can. It is about learning the concepts. Then you can translate it to any other programming language whenever you need to. Understanding the concept of the data structure or the algorithm should be the primary concern. If you have the idea and learn a different language, translating it is not going to be a problem. Also, different programming languages have different strengths, so there is no one size fits all kind of a thing here. You first need to check your requirements and then select a language that is most appropriate for it. Anyways, with that out of the way, let's get started. First of all, let us understand what a binary tree is. Instead of going through the formal definition, let me break it up into smaller points so that it is clear. First of all, a binary tree is a data structure. So it can be used to store data so that it can be used effectively. Second, it is defined as a collection of nodes. These nodes represent values like 1, 2, 3 or ABC, and two nodes are connected via edges. Third, it is a hierarchical data structure. So you start with one node at the top, and this node is called the root node. This node can have two children, then each of its children can have two more children, and then their children can have two more children, which will form this hierarchy. Fourth, each node can have one parent and at most two child node, except for the root node, which has no parent. This makes the binary tree a non-linear data structure since it branches at each node. Next, let me define a few more key terms concerning binary trees. The first is leaf node. A leaf node is a node that has no children. Second, sibling nodes. Two nodes with the same parent are known as sibling nodes. Third is subtree. A subtree of a particular node is a tree that is formed by its children and their children and so on. In this case, this will form a subtree. And lastly, degree of a node. The degree of a node represents how many children that particular node has. So it can be either 0, 1 or 2. And that is all about the theory. Let us move to the code editor and see how we can represent binary trees in JavaScript. Now you can just open up a Chrome console or some code sandbox if you like. I prefer to have a bundler set up with an HTML page and a bundle.js. If you prefer this approach, then you can go to the description below, open the link named start point, then you can go to the start branch, and if you know how to clone it, do that, or download it as zip and open it in your favorite editor. Once that is done, open a terminal like so and run npm install. This will install all the required dependencies. Once that is done, you can start the dev server using npm run dev. And once that is done, you can go into the src folder and open this index.js file. This is the entry point where you can start coding. So getting back to what we were discussing earlier, how do we represent a binary tree in JavaScript? And to answer that, we just need to answer how do we represent a single node. The answer is simple. We can use objects. So each node will be an object. It will have a value property which will store the value. It will then have left and right properties which will point to its child node object. If it doesn't have, let's say, the left child, the left property will be null. So what we can do is this. We can create the root like so. Const root equals to this object. We can give a value of, let's say, 1. And it will have left and right properties. These left and right properties once again are going to be more nodes. So we are going to create more objects. Then the value of the left node will be 2 and the right node will be 3. The left node will be a leaf node with no children. So we can set the left and right properties to null. For the right child, it will only have a left property and the right will be null. So let's create the left object and put the right as null. And for this object, it will have the value as 4 and its left and right will be null. Now if you console.log this, you can see that the object is as we expect it to be really. So you can see that we can represent a binary tree in JavaScript in this way. But you can also see that manually doing this is very tedious. So what we can do is create a blueprint for these nodes with the help of a class and create the nodes using that. So let's do that next. We can create this class called binary tree node and it will have 3 properties. The first will be value, the second and third will be left and right. And we can initialize both left and right as null. So you might be wondering how we can use class properties. Well, using this setup that we have right now, we can use that. Otherwise, you can leave it as it is. It will be undefined instead of null in that case. Next, let's create the constructor function. In the constructor, we will take value as the parameter and we'll set this dot value equal to the value. We will have 2 more functions. The first one will be set left and the other will be set right. And these will be used to set the left and right childs respectively. So we will take node as a parameter for both, and for set left we will do this dot left equals to left, and for right we will do this dot right equals to right. And that should be all. Let's see how we can use this next. So to create node, we can simply do this. Const root equals to new binary tree node of, let's say, 1. Then to set the left property, we can do root.setLeft, and inside we can create new node, so new binary tree node of, let's say, 2. And similarly for right, root.setRight, this new node. And for, let's say, right of left of the root, we can do this root.left.setRight and the new node. And if we console.log it, you can see we have the same structure as before. But then again, this is not a very easy way of visualizing how the binary tree actually is. So don't worry, I have that covered. I've already created a visualizer for binary trees that you can use to easily visualize the binary trees that you create. And I'll leave the link for that video in the description below and also at the end. So do check it out if you haven't already. And good luck and have fun while learning binary trees. I will create videos on binary search trees and AVL trees next, so do subscribe to keep an eye out for those. And do like this video if you enjoyed it and comment what you want me to do next. Can be anything, backend projects, front-end projects, full stack projects, and I'll try to make them. And I hope to see you guys in the next video, so see you then. Bye.